Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by Dr. Robert Mortlock to discuss his recent Naval Engineers Journal article entitled Decisions Facing U.S. Navy for the Future of the Columbia-class Submarine. Dr. Mortlock is a retired U.S. Army colonel and is professor of the practice and associate chair for acquisition sciences for the Department of Defense Management at the Naval Postgraduate School in Monterey, California. He holds a PhD in chemical engineering from the University of California, Berkeley, an MBA from Webster University, an MS in National Resource Strategy from ICAF, and a BS in chemical engineering from Lehigh University. I should note that while I'm interviewing Dr. Mortlock today, he co-authored this piece with Lieutenant Commander Benjamin Field, U.S. Navy. Dr. Mortlock, Bob, thank you for joining me on the podcast. I look forward to this discussion.
Thanks so much, Stephen, for welcoming me to your show.
Bob, this discussion surrounds the Columbia-class ballistic missile submarines, SSBNs, or boomers in the vernacular. What is their mission and what is the importance of SSBNs?
Thanks, Stephen. SSBNs play an integral role in strategic deterrence. 14 SSBNs currently patrol the oceans, provide an undetectable launch platform, and discourage the use of nuclear weapons by U.S. adversaries. The aim of strategic deterrence is to dissuade another country from launching nuclear weapons at the U.S. out of fear of a retaliatory strike. The U.S. uses a nuclear triad to provide a credible and capable source of strategic deterrence. The nuclear triad is composed of three components: air, land, and sea-based deterrence. Air-based deterrence is accomplished by the U.S. Air Force by outfitting airframes with nuclear weapons. The Air Force B-52 and B-2 bombers carry gravity-based nuclear bombs, and F-15 Strike Eagle fighters carry nuclear cruise missiles. The Air Force is also responsible for land-based strategic deterrence. Minuteman III intercontinental ballistic missiles, or ICBMs, are spread out over hardened underground silos ready to strike. Sea-based deterrence is the responsibility of the SSBNs of the U.S. Navy. Each portion of the nuclear triad offers its own unique advantages, but collectively they establish a formidable source of strategic deterrence. The land-based strategic deterrence afforded by ICBMs represents the most responsive leg of the nuclear triad. Meanwhile, the air-based deterrence provides the most flexible leg of the nuclear triad. The U.S. Navy's SSBN fleet, which conducts sea-based strategic deterrence missions, is the only platform that represents a clandestine, survivable threat to the U.S. adversaries.
Currently, the U.S. Ohio-class SSBNs fill this important strategic role. Before them, there was a 41 for Freedom submarine program, and that comprised a number of different classes of submarines. Can you describe the 41 for Freedom and the Ohio class?
Yes, the Ohio class submarine was the successor to the 41 for Freedom fleet ballistic missile submarines, which were comprised of 5 different classes: the George Washington, the Ethan Allen, the Lafayette, the James Madison, and the Ben Franklin. Each of the earlier versions of the fleet ballistic missile submarines carried Polaris missiles and later Poseidon or Trident I missiles. The fleet ballistic missile submarines provided strategic deterrence patrols for years. However, advances in submarine technology and the desire to equip the vessels with Trident II ICBMs led to the development of the Ohio-class submarines. 18 Ohio-class SSBNs were commissioned between 1981 and 1997. The first 4 Ohio-class SSBNs, which completed patrols were then converted to guided nuclear submarines, or SSGNs, from 2000 to 2010. The SSGNs are SSBNs that are outfitted with Tomahawk land attack missiles instead of ICBMs. The remaining 14 SSBNs provide that sea-based leg of strategic deterrence today. Ohio-class submarines are 560 feet long, nuke-powered warships that can carry up to 24 Trident missiles, and they are home-ported in either Kings Bay, Georgia, or Bangor, Washington.
To keep these submarines on station, each has two crews. There's a blue crew and a gold crew. Can you describe how this works, please?
Yes, each SSBN has the two crews, known as blue and gold crews, which operate the submarine on its deployment cycles. One crew takes the submarine to sea for a strategic deterrence patrol that lasts usually between 75 and 90 days. Once the strategic deterrence patrol is complete, the submarine returns to port and the crew turnover occurs. Once the new crew has taken responsibility for the submarine, a 30-day maintenance period begins. When the maintenance period is complete, the submarine goes back out to sea. The crew that had returned from the sea and is in port now operates submarine simulators, conducts training, and plans for the upcoming maintenance period following crew turnover.
How is the Columbia-class different from the Ohio-class?
The Colombia-class will be the world's state-of-the-art SSBN. The Columbia-class will feature a nuclear reactor that, unlike the Ohio-class, requires no refueling for the lifetime of the submarine. The new submarine class will also feature an electric drive propulsion system and an X-shaped stern configuration, which will increase the ability of the submarine to remain undetected. The Columbia-class submarine will carry 16 Trident D5 missiles. This is 8 fewer than each Ohio-class submarine. However, the Ohio-class submarines will maintain the same number of overall missiles at sea because the Ohio-class submarines will not need to conduct mid-life refueling of the nuclear reactor. Fewer lengthy refueling periods result in fewer Columbia-class submarines in port and an increased number of SSBNs at sea.
So let's delve into each of these naval engineering choices. An X-shaped rudder stern plane configuration was described and discussed in episode 24 with Captain Roy Springer, who is the former CEO of USS Albacore. Why an X-plane instead of the traditional configuration with a vertical rudder and a horizontal dive plane configuration?
The X-shaped stern configuration reduces the chance of accidental dive, allowing faster speeds at lower depths, and also improves the acoustic signature of the submarine.
Electric drives have been used before. In fact, I've learned recently that we used electric drives on battleships, believe it or not. So why this approach?
The Ohio class uses a steam turbine drive, meaning the nuclear reactor produces heat, heat makes steam, steam turns the turbine, and the turbine mechanically turns the propeller shaft. The propulsion system is mechanical, not electric. In a nuclear electric drive, the nuclear reactor produces heat, heat makes steam, steam turns the turbine, turbine generates electricity, and the electricity powers a large electric motor, and the motor turns the propeller. The electric drive key characteristics include improved acoustic quieting, unlimited underwater endurance, no need to surface for power, and a very high sustained rate of speed.
Your article suggests the Columbia will never refuel in its lifetime. You said this earlier. How is this accomplished and what advantage does this provide?
The reactor core of the Columbia will be a 42-year life of ship service reactor. The reactor uses a highly enriched, high density fuel, meaning more usable energy is packed into the same physical space. The advanced core design has improved neutron economy, meaning more efficient fission use, optimized geometry and materials, that allows slower fuel depletion over decades. The advantages include saving billions in overhaul costs, avoiding cutting the submarine open, and increasing operational availability while simplifying long-term maintenance planning.
Like all other Navy programs, the Columbia-class has experienced some acquisition challenges. You describe the triple constraint as a balance of cost, schedule, and performance. Anyone in acquisition has heard this triad before, of course. Uh, what must program managers weigh when considering these three acquisition metrics?
As you mentioned, program managers are responsible for managing the triple constraint of the program's acquisition program baseline: cost, schedule, and performance requirements. Though a simple concept, balancing the triple constraint involves complex decisions. A PM can optimize the triple constraint for two of the three variables by making concessions in the third. As an example, the PM could focus on delivering a quality submarine on time, therefore focusing on performance and schedule at the expense of increased overall life cycle program costs. Conversely, a PM could choose to maintain schedule and cut costs for the program at the expense of decreasing quality or performance. However, none of these decisions concerning the triple constraint can be made in isolation.
Yeah, indeed. So, what are the challenges that are facing the Columbia program?
Despite the progress made on the Columbia-class submarine, delays in early construction are threatening timely delivery to the fleet. These specific problems include a smaller supplier base, roughly 70% smaller than in previous shipbuilding booms, an inexperienced shipyard workforce, software development challenges, and a supplier quality problems. If the Columbia-class submarine is not ready to make its first strategic patrol in fiscal year 2031, the initial operating capability date, the U.S. may experience a deterrence gap. These challenges put this 12-ship, $128 billion program at significant risk.
I understand that software issues are a significant part of the challenge. So, what happened there?
Well, Electric Boat, the Columbia-class SSBN prime contractor, switched to a new computer-aided software tool for the Columbia-class SSBN. The purpose of the software tool is to design arrangements, disclosures, and material orders which are required to develop the submarine. The arrangements, which are completed first, are 3D models of the steel structure, the electrical systems, and the piping systems. Once the arrangements have been completed, the next step is to design the disclosures. The disclosures complete the design work for the lowest level of items of the submarine, including material information. The completed disclosure leads to the development of work instructions, which provide shipyard workers with the procedures and the parts required to build any part of the ship, and the material orders, which allow the generation of contracts to order all required parts. Unfortunately, issues with the new software have resulted in delays in disclosure and work instruction completion. In the absence of work instructions, the shipyard cannot begin building portions of the submarine because they do not have the procedures for their workers to follow. Additionally, delays in the disclosure completion have resulted in delayed orders of construction materials.
And what has happened to the supplier base?
Right now, Electric Boat and Newport News are the only two private shipbuilders who construct nuke-powered vessels for the U.S. Navy, and they plan to deliver 39 nuclear submarines over the next 2 decades, which, if achieved, would represent a doubling in output over prior years. The 39 submarines account for producing 2 Virginia-class submarines per year through 2033 and 1 Columbia-class submarine per year starting in 2026. This pace of submarine construction is unmatched since the height of the Cold War. Complicating the problem of increased demand for materials, the submarine supplier base has been shrunk roughly 70 to 80% since the 1970s and 80s. The number of suppliers has decreased from approximately 1,700 to approximately 5,000, representing a significant program risk. In addition to having a smaller and more fragile supplier base that is working at maximum capacity to deliver critical materials for the Navy's most important acquisition program, the number of experienced workers has declined. This has resulted in inexperienced workers delivering substandard quality materials to the Columbia-class lead shipbuilder electric boat.
And Bob, what about quality assurance?
Well, for submarine, quality assurance is vitally important. A strong quality assurance program not only is an industry best practice, but also minimizes the probability of schedule delays and cost overruns. The shipbuilder is responsible for delivering quality submarines that meet the Navy's specifications and tasked with ensuring and monitoring quality based on contract requirements. At this point, however, the Navy has not comprehensively reassessed when additional government inspections at the suppliers are necessary, which is a major driver for schedule delays.
There's a challenge when it comes to estimating the cost of delivering the submarine. Can you describe how this happens, please?
Though the focus of the Columbia-class submarine is delivering the new SSBNs on time, another concern is the cost overrun, which you mentioned in this question. The Columbia-class submarine costs have exceeded the amount budgeted for the submarine, which jeopardizes other Navy construction efforts. The first Columbia-class submarine will be approximately $14 billion, $700 million more than Navy estimates. Though there are reasons why the Navy may be underestimating its cost, there appears to be at least two factors. The first factor is not being able to take advantage of planned cost savings in the detailed design phase due to delays in disclosure completion that we previously mentioned. Second, the Columbia-class program office had optimistic assumptions about the labor hours needed to construct the submarines. It is important to note that accurate cost estimates are a particularly difficult challenge for any lead ship in a new class due to unanticipated costs that were discovered during the acquisition process. Another factor that could lead to increased program costs is the type of contract used for the first two Columbia-class submarines. The first two subs in the Columbia-class are being built under a cost plus incentive fee type contract structure. A cost plus incentive fee contract is a cost reimbursable contract that provides for the initial negotiated fee to be adjusted later by a formula based on the relationship between the allowable costs and total costs. These type of contracts transfer cost risks to the government from the contractor, and the government funds the development costs within the scope of the contract, but above the original baseline estimates. In the case of the Columbia-class submarine, the likelihood of the government incurring costs more than the baseline is high because designing the lead ship in the class is a challenging endeavor, pushing the state of technology with unforeseen obstacles not initially anticipated. The Columbia-class submarines represent a substantial portion of the Navy's shipbuilding budget. Discounting the cost of the first Columbia-class submarine, the most expensive ship in the new class, producing the next Columbia-class submarine will cost about $8 billion per year. The difference between the first sub at $14 billion and the second at $8 billion represents a 60% combined learning and production rate curve. This is extremely optimistic because historically shipbuilding programs see about an 80 to 85% learning production rate effect, meaning the second sub would cost approximately $12 billion rather than the $8 billion.
So, Bob, what's the way forward for the Columbia class?
The U.S.'s nuclear ballistic submarines, SSBNs, are essential for strategic deterrence. There's no doubt about that. The Ohio-class SSBNs are beginning to reach the end of their already extended 42-year service life. Columbia is set to be completed and turned over to the Navy and ready to execute its first patrol in 2031. The Columbia-class submarines will incorporate innovative technologies to include the nuclear reactor that requires the no midlife refueling, an electric drive propulsion system, the X-shaped stern, as well as modern sonar suite and advanced sound silencing capabilities. The issue facing the Navy is risk to that 2031 IOC date. Challenges facing the program include a small supplier base, inexperienced shipyard, immature design software, quality problems with supplier materials, high technical risk, aggressive production schedule, program cost, and an outsized impact of the program on the overall Navy shipbuilding budget. Options the Navy could consider include investing more resources into the Columbia program, extending the service life of the Ohio-class submarines, accepting a strategic deterrence gap, canceling the program, or investing in an Ohio-class upgrade program. Possible decision criteria to compare these options could include maximizing performance, meaning deliver the most required capabilities, lowering costs, meaning lowering the overall total lifecycle cost of the program, delivering on schedule, meaning avoiding the deterrence gap, lowering technical risk, meaning incorporating state of the practice rather than state of the art technologies. To determine the path forward for the Columbia program, senior Navy leadership must balance the criticality of avoiding a strategic deterrence gap and the need to preserve a robust shipbuilding industrial base with program affordability, a desire for maximum performance requirements, and the accompanying technical risk, cost, and schedule to attain those capabilities. How important is the strategic deterrence gap? The answer to this question tells you how important schedule is in determining that. How important is the health of the shipbuilding defense industrial base? The answer relates to the importance of cost and affordability for this program. How important is state of the art versus state of the practice technologies? Greater performance is linked to greater technical risks and costs. The future of the Columbia program, like other major defense acquisition programs, comes down to optimally balancing not just the triple constraint, but the quadruple constraint of cost, schedule, performance, and technical risk.
Bob, is there anything else that you would like to share with the Talk a Little, Learn a Lot audience?
Well, Stephen, it's been a real pleasure to discuss this acquisition program case study with you and your audience. I'd like to highlight that this case study originated from a capstone research project that Lieutenant Commander Ben Field completed while earning his Master of Science degree in Program Management from the Naval Postgraduate School. It's an example of the quality of naval officers across the fleet and their commitment to critical thought, problem solving, decision making, resource management, and stakeholder engagement. I truly believe our national security is best sustained through a commitment to the training and education of our most valued strategic asset, the men and women serving in our armed forces. And I feel honored and privileged to help them achieve their educational goals every day, and humbled to know they are protecting the national security of our great nation.
Yeah, indeed, and amen. Well, then, thank you, Bob. Dr. Robert Mortlock, for taking this time to discuss decisions facing U.S. Navy acquisition of the Columbia-class submarine. I encourage everyone to read this article in the Naval Engineers Journal, and I hope we can welcome you back, Bob, to Talk a Little, Learn a Lot, the podcast of the American Society of Naval Engineers.
Thank you, Stephen.